All right, so in C Sharp, you have different data types, right? Variable types. And I'm going to use the word type a lot. And when I say the word type, I don't mean like typing in a keyboard. I mean like category of data, all right? So when I say the word type, I mean basically synonymous with like category or kind of, all right? So we have different pieces of data that we're going to have to store in our program. Could be people's names. It could be the like total amount of their shopping cart. It could be whether or not they're a premium member. That's for just for e-commerce. There could be all sorts of things in our application because people can build applications to do all sorts of things. Position of a car in a freeway, if you're doing like a Google Maps kind of thing. If you're doing some other kind of program, it could be a completely different set of data. So because we have all this data, the data comes in different varieties. Some data is in the form of numbers, right? Like ages or shopping cart totals or XYZ position of a robot. Basically, your imagination's the limit. All right. There's other kinds of data that's not numbers, where it's like people's names or locations or things like that. Other kind of data could be whether or not someone is a premium member or whether or not someone is a manager. Okay, so they could be off-on kinds of data. Right, but all this data has to be put into the computer, and the computer has to know what kind of data it's working with. Because we're learning C Sharp, C Sharp is a statically typed language. What that means is when you give it a piece of data, it needs to know the kind of data it's working with. What type of data is it? It needs to know the type. All right, and when you declare a variable, you need to also tell C Sharp, hey, this variable is of this type. So let's look at the first one, which is an integer. All right, so the way in C Sharp that you declare variables is first you get the type, in this case int. Okay, so this part is always going to be a type, int, long, float, double, whatever it happens to be. Then you give it a name. Common beginner mistake is to think that this name has some sort of magic powers, like the computer knows what this is. It does not. This name is something we come up with entirely on our own. We could just as well call this Aardvark or Superman or Captain America. Like the variable name is just literally a label that the human being comes up with. Now you'll see in programs when we create variable names, we give them logical names like first name, last name, things like that, so that we and other programmers understand what the variable represents in the real world. But just keep in mind, the computer has absolutely no understanding at all of what the variable represents in the real world. It's just a label that we put on it, and we could just as well put another label on it as we feel like. All right, but the pattern is always going to be int. So the type of variable we're working with, what category of data are we working with? Then we're going to give it a label, and then we're going to set equal to something. So in this case, I have integers, which is for whole numbers. All right, so I have this really big number right here. Right, an integer is when we want to have a whole number, basically a number without decimals. So it's going to be there's not going to be a point something 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 afterwards. Right, it represents an integer. All right, now there's another type called long, okay, which does the same thing. It's also for integers. The difference between int and long is basically the maximum value or minimum value it can hold. So what I mean by that is, notice how I have int whole number equals this huge gigantic number, right? So it's like 483,000. So it's like 2,147,483,647. Big gigantic number. Notice how if I raise it by 1, okay, so if I go up by 1, the compiler marks this as red. Because remember, C Sharp is a compiled language. The compiler checks to see if there's errors. If there are any errors, it will not run. So it's red. Why is this red? We hover over it. Represents a 32-bit unsigned integer. All right, so basically it's saying like, hey, did you mean like this unsigned integer? Is that what you meant to use? And the reason it's saying this is because this number is too big to be represented by an integer. So this number is the right size. Anything above this, integer cannot hold it. You can think of integers, the difference between integer and long. Integer is a smaller box than long. Integer can hold less data than long can. So long, you can have a huge, gigantic number like this, and it's perfectly fine. All right. Most people use integer in their daily life. Some people use long. For the most part, the only thing you really have to remember is that long can hold bigger numbers than integer. And again, if you also make it negative, all right, it will work in the opposite direction for negative. All right. So int and long are for whole numbers. For numbers that have a decimal after it that need or maybe they're like irrational numbers or numbers with a fraction, then we have float and double. All right. And again, the difference is the same. Float cannot hold as a big of a number as double can. all right? But the main thing about them is that they have numbers that are fractional. Like they have 1.123, 54.234. Anytime you have a number that has a decimal to it, you're going to need to use float or double. Notice how, let's say I did like int, this doesn't work, equals 5.45. If I try to do this, okay, it will give me a compilation error because integers have to be whole numbers. It will give you something like cannot implicitly convert. Basically, what the compiler will do is like, oh, you said this was an int, but you gave me a double. I'm going to try to convert it, but I can't. Okay, what that basically means is it's like, hey, the two don't match. Notice how with float I put an F at the end. Okay, if I take this out, you'll get a compiler error again because essentially when you don't put, if you have a number with a decimal and you don't put a letter after it, it's going to assume it's a double. So we put F here to let the compiler know, hey, this is a float. All right, and then everything's hunky-dory. And again, the only difference between these two is that double can hold bigger numbers. Okay, pretty much you're going to use double most of the time anyway. People use float, long, int. I mean, you'll see in the real world, people do what they feel like doing. Stick with int and double for right now if you're just a beginner. Now, if you're wondering, well, Jonathan, what's the actual max value that I can hold with one of these, like int, long, float, or double? Well, you actually can check. There is a special property called max value. I did float.maxvalue.toString, and I'm going to run the program real quick by hitting this run button up here. It will compile, build, and then you can see that, hey, like this is the maximum, like the maximum float value is this number, the maximum double value is this ridiculous number, the maximum integer value is this, and the maximum long value is this. And you can see that clearly, like, float is smaller than double, integer is smaller than long. That's the main thing you need to like learn. I would not memorize the maximum values. That is rarely, if ever, a thing you need to worry about, because again, if you actually go over or under, like, the compiler will let you know that you've made a mistake. So I would not memorize that. It's just a piece of trivia. Other types of data that we can encounter for example, decimals. Decimals are great for when you're like working with money, like with transactions or anything financial. We indicate a number as a decimal with M because M is for decimal. D was already taken, so they just went with M. So again, if I don't put M on here, it's going to give me a compilation error, the red squigglies. So I have to put M to signify to the compiler, hey, this is a decimal. All right, and then we do 10.54. And again, my personal recommendations when you're working with transactions or money, use decimal. All right, then we have Booleans, which is like an on and off switch, true or false. Okay, there's only two options. Okay, are they a premium member? Yes or no. Is the light switch on or off? Anything sort of 1 or 0 kind of value you can use a Boolean for. And again, we say bool, name of the Boolean equals true, and the other value could possibly be as false. Okay, either one of those works. Strings are for anything that are not numbers. That you don't do math with. The way I kind of like let people, like for beginners, the rule of thumb for like string versus like a double could be like, hey, are you going to do math with it, right? Because a string could have letters, just like we had this name Steve Rogers, but you could also put numbers in here and symbols, okay, as much as you feel like. All right, letters, numbers, and symbols, it's all good. You need to use double quotes in order to make something a string. So when we do double quotes, that indicates to the compiler, hey, this thing is going to be a string. All right, so when you see me say that we're going to make a string, and I just start putting in quotes, that's what I mean. So again, follow the same pattern. String, name of variable equals double quotes, and then inside the quotes you could put letters, numbers, or symbols, okay? Spaces, whatever you want to have in here. Some more esoteric, less used, but still good to know data types in C# are byte. Bytes come into play like a lot of times with like files. When you're like taking files and like uploading them or downloading them, although you don't really need to know much about that. We have like arrays of bytes that sometimes comes into play. A byte can hold a value between 0 and 255. All right, so if you probably put 256 in here, it's going to give you a compilation error, right? It's for its value between 0 and 255. And char is for a single like letter, right? So notice I put single quotes. Okay, char is single quotes, string is double quotes. And then inside you could put a singular letter. If you try to put more than one, you will get a compilation error basically saying too many characters in character literal. Basically saying, hey, this is a char, and you said it was a char, so therefore it's got to be just one letter. That's it. All right, these are all the data types. Now to go back to the idea of C# being a statically typed language, some people say strongly typed, some people say statically typed. It basically means that once you decide a variable is of a certain type, you cannot change it. So, for example, on line 22, I have string name equals Steve Rogers. I can change that to another string. I could be name equals, I don't know, Wanda Maximoff. And then I can be name equals, I don't know, Scarlet Witch. Whatever, right? You can go ahead and change it from one string to another. I can't change it to an integer. I cannot do name equals 10. All right, the compiler will give me an error noted by these red squigglies. I'll hover over it. Cannot implicitly convert type int to string. What this means is name is a string, but you're telling me it's equal to an integer. Those two things don't match. Strings and integers are of different types. They cannot go together.